Hi everyone, welcome back to my YouTube channel, Chemistry with Sumitpramar. Today we'll be solving past paper from year 2018, October-November series, paper code 970111. Let's look at question number 6, which says, a butane burner is used to heat water. The molecular mass of butane is 58. The first statement is, enthalpy change of combustion of butane is 2877 kilojoule per mole. That means if you burn 1 mole of butane, you will get this much amount of energy. Second statement is 250 grams of water is heated from 12 degrees Celsius to 100 degrees Celsius. If I want to draw the setup, it would be, we have taken 250 grams of water. Let me draw the setup. Let's say in the speaker we have taken 250 grams of water, and we are heating it with the burner which contains butane, right? And the temperature of the water rises from 12 degrees Celsius to 100 degrees Celsius. That means the change in temperature delta T is 100 minus 12, which is 88. The burner, third statement is, the burner transfers 47% of the heat released from the burning fuel to the water. That means whatever heat is being released from butane burning, only 47% of heat released is absorbed by water. Let's see what is the heat absorbed. Heat absorbed by water. Q is equal to mc delta T. This is the amount of heat absorbed by water. Mass of water is 250 grams. Heat capacity of water is 4.18, and delta T, change in temperature, is 88, and this comes out to be 91960 joules. That means this is the amount of heat absorbed by water. And as we know that this is only 47% of the total heat released from burning the butane. That means total heat, if QT, let's say this is the total heat released, out of this only 47% of this is being absorbed, which is equal to 91960. So if I calculate QT, it will be 91960 divided by 0.47, which comes out to be 195.66 kilojoules if I convert it into kilojoule. Now this is the amount of heat released by butane, right? We have to calculate what is the mass that must have been burnt to release this much amount of energy. From the first statement we know that 1 mole of butane gives this much amount of energy. So let me erase this part. One mole butane gives 2877 kilojoule of energy. So how many moles of butane should be burnt to give 195.66 kilojoule of energy? So for that we can divide 195.66 upon 2877, and we get 0.068 moles of butane. That means these many moles of butane should be burnt to give the required amount of heat. If we want to convert this into mass, we need to multiply with the molecular weight. So mass of butane is equal to 0.068 times 58, which is the molar mass of butane, and it comes out to be 3.94 grams. So option C is the correct response. Question number 7. Nitric acid is known to take part in the oxidation of atmospheric sulfur dioxide. One possible reaction is shown. Which row shows the correct changes in oxidation number of nitrogen and sulfur? That means we need to calculate the oxidation number of sulfur and nitrogen in all of these species. So sulfur, if I look at the oxidation number of sulfur here, let's take the oxidation number of sulfur as X. For oxygen, we know that the oxidation number is -2. Since there are 2 oxygens, well multiplied by 2 for each oxygen, the oxidation number is -2, which is equal to the total charge, which is 0. So X minus 4 is equal to 0. X is equal to +4. So the oxidation number of sulfur is +4. Similarly, if you do the calculation for nitrogen, it comes out to be +5. Now for this one, nitrogen, this is, let's take the oxidation number of nitrogen as X plus oxidation number of oxygen is -2, and the total charge, which is equal to the total charge, which is +1. X minus 2 is equal to +1. X is equal to, erase this, X is equal to +2 plus 1, which is equal to +3. So oxidation over nitrogen here is +3, and similarly for sulfur it is +6. Let's look at the total change in oxidation number. So for nitrogen, it changes from +5 to +3, which is 5 minus 3, right? 3 minus 5, which is -2. For sulfur, it increases from +4 to +6. There is a +2 oxidation number change. So option B. Question number 8. A transition metal ion M2 plus reacts with acidified dichromate ions to form M4 plus ions, Cr3 plus ions, and H2O. Which equation correctly represents this reaction? We know that for a balanced equation, total atoms should be balanced on both sides and total charges should be balanced. If I look at all these 4 options, I can see that total number of atoms of each of the species are balanced on both the sides. So let's look at total charges on both sides, left hand side and right hand side of the reaction. Let's look at option A. There is 2 negative minus 2, 14 positive plus 14 plus 2, which comes out to be +14. Let's look at the right hand side. 2 3s are 6 plus 6. This is neutral. This is 4 plus, which is +10. These are not equal. Option B. There is 2 negative minus 2, 14 positive plus 14. There is 2 2s are 4 plus 4, which gives us +16. Now let's look at the right hand side. 2 3s are 6 plus 6. This is neutral. 2 4s are 8. 8 plus 6 plus 14. Both are not equal. Now let's look at option C. There is 2 negative. There is 14 plus. 3 2s are 6. 3 2s are 6, which comes out to be +18. Let's look at the right hand side. 2 3s are 6. This is neutral. 3 4s are 12 plus 12, which is equal to plus 18. Both are equal. You can check for the last option also. They won't be equal. So option C. Question number 9. In this question, you should assume that all gases behave ideally. Hydrogen and iodine react reversibly in the following reaction. The system reaches dynamic equilibrium. Which statement must be true for the Kp of this equilibrium to be constant? As we know that Kp, rate constant, is it depends on temperature only. It is not affected by any other factor like pressure or anything else. That means if the temperature remains constant, Kp remains constant. Hence, D should be the correct response. Question number 10. 0.2 mole of sulfur dioxide and 0.2 mole of oxygen are placed in 1 decimeter cube sealed container. The gases are allowed to reach equilibrium. This is a given reaction. At equilibrium, there is 0.1 mole of SO3 in the container. What is the value of Kc? In order to solve this, we need to make Rice table. R stands for reaction, which is 2SO2 plus O2 gives us 2SO3. Initial concentration, change in concentration, and equilibrium concentration. Initially, there is 0.2 moles of sulfur dioxide and 0.2 moles of oxygen. We can take directly moles as concentration because the volume is 1. If you divide by 1, you will get the same answer. And initially, there will be 0 moles of SO3. From the given data, we know that there is 0.1 mole of SO3 in the container at equilibrium. So at equilibrium, there is 0.1 mole of this one. So the concentration of SO3 is changing from 0 to 0.1. So there is plus 0.1 mole change. As we know that 2 moles of SO2 reacts to give 2 moles of SO3. So 0.1 mole of SO3 will be produced from 0.1 mole of SO2. Since reactants are being consumed, so we'll put negative sign. Right. Now from the stoichiometry, we can see that 2 moles of SO2 reacts with 1 mole of O2. So 0.1 mole of SO2 will react with half of it. That means 0.05 moles of oxygen. Let's calculate the equilibrium concentration. 0.2 minus 0.1 will give me 0.1 mole of SO2. 0.2 minus 0.05 will give me 0.15 moles of oxygen. Let's write down the expression for Kc, which is Kc is equal to concentration of product, which is SO3 raised to the power 2 stoichiometric coefficient upon concentration of SO2 raised to the power 2 into concentration of O2. Let's substitute the values. For SO3, it is 0.1. So 0.1 square divided by concentration of SO2 square, which is 0.1 square, times 0.15, which is the concentration of oxygen. Since both of these are equal, can be cancelled out. So Kc is equal to 1 upon 0.15, which comes out to be 6.67. Hence option D is the correct response. Thank you for watching my video. Please like, share and subscribe to my channel, Chemistry with Sumit Pramar.